is that it's 40 times more vulnerable to stress along the grain than across it. That's why you split wood with an axe by chopping into the top and not horizontally against the side.
When you split a piece of wood along that axis, the cells peel off apart.
But by cross-layering thin strips of wood at right angles, the grain weaves together to create perpendicular bonds that give ordinary wood fibers super strength.
Well, plywood was developed to try and get around some of that problem with all of wood's strength being in one direction.
This may seem like modern technology, but it turns out that plywood has been used since the Gerson period of ancient Egypt, 5,500 years ago, and it was made much the same way. Thin strips of wood called veneers were glued together to create plywood, but the process was time-consuming and expensive. Then, in the 19th century, thanks to rotary lathes and improved bonding agents, plywood became one of the most affordable building products available. The first engineered wood, known for its great strength and low cost. Because every piece of wood is valuable, the laser-guided cutting ensures a minimum of leftovers. But it turns out even those have value. All the wood scrapes and sawdust are sold to companies that press it into boards or burn it as fuel.
We waste nothing. In today's world and the market, with timber values where they're at, we can't afford to waste anything.
So what about the cellulose? It's the lignin that gives wood its great strength. But what about the rest of it? All that white stuff that makes up most of the inside of a tree? That's cellulose. And while it may not be as strong as lignin, it does have a surprising ability. It's incredibly flexible. One of the ways we take advantage of cellulose is in paper. In fact, paper pretty much is flattened tree guts. The invention of paper goes back thousands of years. The Egyptians had a version called papyrus, made from a reed of the same name. But true paper, paper made from processed cellulose, dates back to 200 AD China, where it was first used as a wrapper, long before it was used for writing. And the basic way of making paper? Boiling wood chips until the cellulose breaks down, pressing the goo into sheets and drying, has remained.
Stand surfaces around 220 up to 300 degrees on the dry end. We gradually dry the paper as it goes through the process. A little over 100 dryers on each machine. Pretty much like cooking a steak, you just gradually cook it until it's done. Comes out the other end about 4% moisture.
Now spools literally reel in single sheets of paper, stretching the length of 40 football fields. Every day, the U.S. uses 400 million gallons of gasoline. But from global warming to international crises, oil comes with a host of problems. Not only that, it's running out. And the question is how to find a domestic source that can provide enough energy. And it turns out that source could be as close as the nearest tree. Is getting that energy out of the tree and into the gas tank. The most prominent biofuel in use today is ethanol made from. It takes more than a gallon of oil to make a gallon of corn ethanol. Even worse, corn ethanol is made from the kernels, from food, the edible part of the plant. Which means every kernel of corn that goes into making gas is one we can't eat. Which is where wood comes in. Today's forests cover more than 9.6 billion acres. And every one of those trees is a giant storehouse of energy. In fact, scientists estimate that cellulose from 1 acre of trees can generate as much as 10 tons of biomass. And with improved processes, those 10 tons can become 1,000 gallons of ethanol, enough fuel to run a car for more than a year.
We get samples of biomass from a variety of sources, from either going out into the fields and getting samples from natural trees, to actually going into the greenhouse and taking genetically engineered and altered trees.
This is an example of a tree that was growing fairly fast. It's only 6 years old. You cut down the tree, so you chip the wood into smaller pieces, and then you basically convert that wood into alcohol. And we can remove the alcohol from the vat where it's being created. Generally what happens then is they transport it to a place where they mix it with gasoline, so you get that 10% E10 fuel that you see at your
Tree leaves turn sunlight and carbon dioxide into energy. In corn kernels, that energy is stored as starch. But a tree isn't like a gas pump. All that energy is stored as a carbon-based sugar in the part of wood called cellulose.
Cellulose is the most abundant biopolymer on Earth. It's in wood. It's about half of wood substance.
Tapping into cellulose is the holy grail on the quest for energy independence. And because tree cellulose produces twice as much ethanol as corn per pound of biomass, trees could be the best renewable source of alternative fuel.
The U.S. has a goal by the year 2020 of producing 36 billion gallons of ethanol, and that would represent about a third of the gasoline that we're using.
We're wanting microorganisms that can directly attack the wood material. We want the primary goal to be making fuel.
The real solution to making cellulosic ethanol a viable alternative to gasoline will require more than just a better microbe. It will also require a better tree. The ultimate fuel tree will have lots of cellulose, as little lignin as possible, grow incredibly fast, and in just about any conditions.
We want a plant that grows very fast, can survive whatever nature throws it, and doesn't require a whole lot of fossil fuel or inputs to grow.
For these scientists, the focus of their work is hybrid poplars. Poplars already have many of the characteristics of the ideal fuel tree. They're hardy, naturally fast-growing, low in lignin, and grown in vast farms for pulp.
Actually make wood into energy sources in more efficient ways. I believe that we can produce a significant amount of our fuel from bioresources.
From dinosaur food to a new source of fuel, trees have completely transformed the world. Strong, light, nailable, and recyclable. They are a miracle material that surrounds us every day, one that may still hold new surprises.